Good morning. Today, we're going to report the wave and particle theory. The members, Ian Pataksil, Pedrero Mark Ismael, Paul Ico, Leonis Rodian, and Arinwelo Ashley. Today's agenda, we're going to discuss wave theory. The second one, the corpuscular theory. The third one, Davison and Germer experiment. The fourth one is photon theory, and the last one is photoelectric effect.
Hi, I'm Paul Axel Ico from page 28, and for today, I'm going to discuss you the wave theory of light. Did you know that in 1690, Christian Huygens, a Dutch astronomer and physicist, proposed the wave theory of light? This theory states that light is a longitudinal wave and transmitted by an ether. And if you're wondering what is ether, ether is a mystical substance that exists and fills up the space in the universe. Christian Huygens believed that the ether moved in the same direction as light and formed a wave which carried all the light waves. Light is a wave and it undergoes diffraction and interference.
The light theory of Newton is based on the idea that light is made up of tiny particles. To describe reflection, we employ the concept of this theory. Theory can explain primary and secondary rainbows, but it cannot explain an iridescent cloud or an extra bow. Newton put forth the corpuscular theory of light in 1704. Using this theory, he was able to explain how light behaves. The simplest theory of light, the corpuscular theory, assumes that light is made up of tiny particles known as corpuscles. It is commonly referred to as Newton's theory of light or the particle theory of light. Unlike atomism, which assumed that atoms could not be divided, corpuscular theories allow for the possibility of division. In this way, they are similar to theories of atomism. The shape, size, color, and other physical properties of corpuscles influence their functions and effects in phenomena in mechanical and biological sciences. They are single, infinitesimally small particles. The modern concept of compounds having secondary properties distinct from those of their constituent elements develop out of this. It is claimed that corpuscles are particles that carry other substances and are of various types according to Gassendi.
Who is Davison? Clinton Davison, the American physicist born 1881 to 1958. Clinton Joseph Davison was an American physicist who won the 1937 Nobel Prize in Physics for his discovery of electron diffraction in the famous Davison-Germer experiment. The partner of Clinton Davison in his experiment is Lester Germer. Who is Lester Germer? American physicist born 1896, died in 1971. Lester Halbert Germer was an American physicist with Clinton Davison. He proved the wave-particle duality of matter in Davison-Germer experiment, which was important to develop of the electron microscope. The Davison and Germer experiment established the wave of nature of electrons and validated the de Broglie equation for the first time. De Broglie proposed the dual nature of the matter in 1924, but it wasn't until later that Davison and Germer's experiment confirmed that the findings provided the first experimental verification of quantum mechanics. They shall investigate the scattering of electrons by Ni crystal in this experiment. As in the figure below, the experimental arrangement used by Davison and Germer is schematically shown in figure below. By applying a sustainable potential or voltage from a high voltage power, electrons emitted by the filaments of the electron gun are accelerated to the desired velocity. They are made to pass through a cylinder with a fine hole along its axis, producing a finely collimated beam. Now, this collimated beam is made to fall on the surface of a nickel crystal.
Photon theory proposed by Maxwell. It, a photon is a tiny particle that comprises of waves of electromagnetic radiation. As shown by Maxwell, photons are just electric fields traveling through space. Photons have no charge, no resting mass, and travel at the speed of light. Photons are emitted by the action of charged particles. Although they can be emitted by other methods, including radiation decay, since they are extremely small particles, the contribution of wave-like characteristics to the behavior of photons is significant. In diagram, individual photons are represented by a squiggly arrow. The light emitted has a wavelength that corresponds to various colors. It appears as a series of colored lines interspersed between the black spaces. Einstein proposed that radiation is particulate made out of particle, not waves, occurring as quanta of electromagnetic energy packets, later called photons. And here are additional discoveries. Astronomers developed maps of our galaxy and its neighbors by imaging the microwave sky. They detect space dust that blocks their view of distant stars by detecting its infrared lights.
Photoelectric effect. The photoelectric effect is widely studied in the fields of quantum chemistry, condensed matter physics, and solid state chemistry because it helps draw inference on the properties of solids and the properties of atoms and molecules. Furthermore, the photoelectric effect is known to have a wide range of application in electronic devices that are designed to specialize in the emission of electrons in a precisely timed manner. Also, it can be noted that this effect has application in the design of electronic devices that can be used for light detection. Increases in light intensity corresponded to an increase of photon absorption, whereas photon energy remained constant.